This presentation is going to be an overview on the use of high voltage test equipment to test aerial lifts. This is a popular application for AC and DC high voltage test systems. In this presentation, we're going to review what is an aerial lift device, when are they used, the testing of aerial lift devices, and how Hipotronics supplies necessary equipment for the proper testing of these aerial lift devices. Aerial lifts, or bucket trucks, are used frequently in utility work, vegetation management, and in infrastructure maintenance. Aerial lifts are useful tools for companies that do work at raised elevations, but this often puts their workers in hazardous situations such as near energized power lines. There are three categories of aerial lifts that are the most common for utility and high voltage work: Category A, B, and C. In addition, there are also Category D, E, insulated aerial ladders and insulating vertical towers. Category A aerial lifts are used for bare hand work, and so the boom insulation is the primary form of insulation. Category A aerial lifts also have a lower test electrode system. Category B aerial lifts are similar to Category A, but the boom is not considered primary insulation, and so work in a Category B device requires the use of gloves, live line tools, and other personal protective equipment. Category C aerial lifts are very common for most distribution work, and the boom is not the primary insulation, meaning that work done in a Category C aerial lift must be done using gloves and other PPE. Category C devices do not have a lower test electrode system. Aerial lift devices come in different sizes and boom designs to meet the challenge of working at heights. There are two main types of boom design: articulated and telescopic. Articulated booms fold out to reach the desired height and fold back onto itself when in transport. Telescopic booms expand to reach the desired height and retract for transport. Some of the larger aerial lift devices may feature both designs. Aerial lift devices may put workers in close proximity to dangerous high voltage lines. Aerial lift devices, or bucket trucks, with electrical insulation are to protect the worker in the bucket, the operators of the vehicle, and those working near the vehicle. Electrocution is one of the leading killers for those in vegetation management and is a very real danger to linemen and other trained personnel who use bucket trucks. To make sure that the insulation is still adequate to protect the workers, the insulation must be tested regularly and properly. There are industry and safety standards that act as guidelines to make sure aerial lift devices are tested properly. Most companies have their own test procedure that are based either on the ANSI 92.2 or IEC 61813 standards. Other standards, such as the OSHA 1910.67, also provide guidelines on how to test aerial lift devices. Most standards call for three types of tests: design tests, qualification tests, and periodic tests. High voltage testing is performed on insulating booms, chassis insulating systems, insulating liners, and upper control components. Aerial lifts should be tested at minimum once per year and after any repair or replacement of components that cross insulating systems, such as hydraulic hoses, boom coatings, and the like. This chart is from the ANSI 92.2 standard, and it details the correct testing parameters for design and quality testing the installation of insulated booms for Category A and B aerial devices. This chart is from the ANSI 92.2 standard, and it details the correct testing parameters for design and quality testing the installation of insulating booms for Category C, D, and E devices, as well as the test parameters for design and quality testing for insulating aerial ladders and insulating vertical aerial towers. This chart is also from ANSI 92.2 and details the guidelines for periodic testing of insulated booms for Category A and B aerial devices. This chart is from ANSI 92.2 and it details the guidelines for periodic testing of insulating booms for Category C, D, and E aerial devices, as well as insulating aerial ladders and insulating vertical aerial towers. In addition to the boom insulation testing, the liners that workers stand in must be tested. Liner testing often requires higher power test systems than boom testing due to the use of conductive liquids to ensure that there are no holes in the liner. This test has no leakage current requirement. The voltage must hold for the allotted time. Another component that needs testing is the upper control components. The insulated pieces surrounding the controls. This is a more difficult test to set up since additional materials such as an insulated blanket may be needed to prevent arcing to materials that are not under test. Watch for surface tracking along nearby fiberglass and other nearby surfaces. Chassis insulators must also be tested to ensure safety to those working near the vehicle. Chassis insulating systems are to protect personnel if energized conductor comes into contact below the boom insulation. Chassis insulating systems have both design, quality, and periodic testing criteria as well. When testing the dielectric strength of insulation on bucket trucks, it is important to note whether an AC high-pot test is needed or a DC high-pot test is needed. AC high-pot testing is necessary for design or quality testing, while DC high-pots can be used for periodic tests. Another key difference is that AC high-pot testing will measure both real current and reactive current, whereas the DC test will only measure the real current. An AC high-pot test will almost always show a higher leakage current than a DC test. This diagram is an image of the ANSI 92.2 standard, and it illustrates the connections for testing a Category A or B aerial device. Do note that shunting jumpers should be placed over joints and the chassis insulating system. This test is done with the chassis of the aerial device grounded. When performing a test like this, it is important to set up your high-pot tester for a grounded test object. This diagram is an image in the ANSI 92.2 standard, and it illustrates the connections for testing a Category C aerial device. This diagram is for testing the aerial device is in a floating mode, meaning ungrounded. Note that shunting jumpers shall be placed over joints and chassis insulating systems similar to the previous diagram. Key differences is that the aerial device is ungrounded, insulated from the ground using insulated platforms under the wheels and outriggers. Make sure that when doing a test in this configuration, that the high-pot tester is set up for testing a floating test object. This diagram is also an image from ANSI 92.2 standard, and it illustrates the use of shunting jumpers for testing the chassis insulating system. When testing the chassis insulating system, it is recommended to test in a floating mode, similar to testing Category C aerial devices. This diagram is an illustration of the description given in ANSI 92.2 for testing bucket liners using a conductive liquid. The bucket liner is placed in a grounded water tank, and the conductive liquid is placed inside the liner. The high voltage output is then placed in the liquid, and the voltage is brought to the necessary testing voltage. If the voltage holds, meaning the high-pot tester did not trip due to short circuit, then the test is passed. This diagram is a simplified schematic depicting the testing circuit for testing the upper control components. 1 is the high voltage source making connection to 2, which is the operator side of the insulator 3. 4 is the boom side of the insulator, which is connected to 5, the current meter. This area can be tight spatially and may require a dielectric blanket or other insulator to prevent surface tracking to nearby surfaces. Hipotronics designs and manufactures various equipment for both AC testing and DC testing for aerial lift devices. These include, but are not limited to, the HVT DI series, the 700 DI series, the MSR, 880PL-HD, and the 8175PL. This table illustrates the various product offerings made by Hipotronics for aerial lift device testing and shows which Each product offering is capable of testing according to the ANSI 92.2 guidelines. This presentation is an overview on high voltage testing of aerial lift devices. If you or your organization has questions on aerial lift device testing or is interested in high voltage test equipment for testing aerial lift devices, please contact a Hipotronics sales engineer by calling our sales line at 845-230-9245 or send an email to sales@hipotronics.com.